So we're looking at just how to graph linear functions. We have this equation here. How would we set that up to graph? What would we do? How do we put this equation into... Alrighty, so we've got to isolate and set it up. Go ahead and do that. And so there's really two ways you could do it. Well, this one is saying to find the x and y intercept. What is the x-intercept? And what's the y-intercept? We talked a minute ago how to find those. Remember to cover up x if you want to know y, cover up y if you want to know x, and solve. X-intercept is 4. Is it positive or negative? Positive. And the y is negative 6. Are y'all good with that? You see how we got it? You said negative 3x equals negative 12. And then you said 2y equals negative 6. 2y, equals negative 12, and then that gives you negative 6. So then, remember the x is the one going across. 1, 2, 3, 4. The y is up and down. And here is our line. Then our second one says to graph this using the slope and the y-intercept. So we're going to have to rewrite it. What would your formula, what would it be when you finish? We're going to isolate y and have y equals mx plus b. What would we get?
Negative 6 plus 3 over 2x.
All right, I see what you did. You just did number 1. Right.
Oh.
But see, we can use our intercepts to graph. So for number 2, what would be our y equals mx plus b? What would be our equation to graph for that one? We'll have y equals what? It's going to be negative 2, but what's going to be our full equation for slope intercept? What will our slope be? Y equals 1 over 4. And minus 2. And that means we go to negative 2, and then we go up 1 to the right 4. And then we graph. All right, those work great when we just have lines and they're pure and nothing is off. Yes, ma'am.
You work on?
Sure. So you're trying to get y equals mx plus b. And so I did negative 4. I'm going to erase right here. It'll be negative 4y equals negative x plus 8. And then divide everything by negative 4. And so y would be so 2 negatives will give us a positive. So 1/4 x minus 2. 8 divided by negative 4. Does that work? Hensley?
Yes.
Does that click? Okay.
Yes.
All right, so there are times when we want to make sure you know that our slopes can be positive or negative. And in this case, both of our slopes were positive. Here's an example of a positive slope. We can have a negative slope, which is going in the other direction. All right. But there are going to be times when our data doesn't really make a beautifully straight, perfect line. And so we have what we call a scatter plot. And a scatter plot is just a graph of a set of points. And the correlation means how the points in the scatter plot are related to each other. And so, do you see, while in this first example, they don't form a straight line, but they kind of form the thoughts of a positive line? So we're going to say this has a positive correlation. And then this second one, while it's not a perfect line, do you see it's forming sort of a negative looking option? So we're going to call that a negative correlation. What do you say about the third one? Do what? It's just like all over the place. It's just free. There is no correlation. So the way your X reacts to your Y, it just doesn't happen. So, what would you say about number 1? No correlation. Number 2. And number 3. All right. I'm just going to do like null, negative, positive. Okay. So we have something more. Sometimes there is no single line that passes through all the points. That's what we call it's called a scatter. The data are all over the place. So you try to find a line that best fits the data that we could, because we still have to have an equation here. And so fitting a line to data is called finding the line of best fit. It's not perfect. It's not absolute. It doesn't take in every single piece of data, but it pulls the data in kind of close to each other. You know, it's making a connection. Or linear regression. Okay, here we go. Here is when it's time to pull out your handy dandy calculator. And I'm going to hand you a sheet. Guys, notice it's in color. I would suggest that you maybe put this in a special spot in your notebook. This is not something to, oh good, we used it on Tuesday and now I'm throwing it away. I would hang on to this until you're through taking the ACT, or until you've got it memorized so well that you don't need this sheet, okay? All right, so what we're going to do is take our data on this first one. They've just named them X and Y. They have not given it a topic. And you're going to go to the home. You know where the home page is. It's that little, top right. And it tells you on this sheet to press new document. And then go to list and spreadsheets. Are you with us? Luke, have you gotten there? Uh-huh. So we've gone to the home and we have a new document, and we've gone to list and spreadsheets, and then you're sitting in a box. I would go hit the tab button. It doesn't say that, but I find it easier. Just hit the tab button, and that takes you all the way up by the A. Are y'all there? And type X. That's like your variable. And then the down button twice to now you're on row 1. And then you're ready to type. So you would do like -3, enter. -2, enter. Y'all with me? Before you go any further, make sure that, like, recheck your data. Be sure that you didn't skip and grab a Y and put it where the X is. So you should have -3, -2, -1, 0, 1, 2. And then I would hit the tab button. It takes you back up to X, and then you can just go over to the right. And under B, you'll type a Y. And then go down twice. Does it still am I making sense? Are you able to keep up with it? Then type in your values for your Y. All right, then you're going to follow the direct. Are we all good? We've got the data in. All right, you're going to now follow the next steps. Just hit menu, and you'll do statistics, which is 4, and then stat calculations, which is 1, and then you're going to pick the one that says MX plus B, which is 3. Okay, your X list. Kind of hit your right button and you'll be able to pull down and just select X and then hit enter. Then go down and do the same thing for Y. Then you're going to go all the way down until you've highlighted OK. Just keep traveling down till you get to OK. And hit enter.
Wait, what do you do on trip to learn this part? You type export. Do you delete this?
You go to the right and you pick, yeah, and hit enter, or that. Then go down and go over to the right. And now keep going down to get to OK.
Wait, what do you do after this part, Dr.
You click and then click X.
Only from the numbers.
And then just keep going down to OK.
Is it like -1.5?
That's going to be your what?
Linear regression.
Fix that. No. I mean, not you, you're good. Now, go to click the right button, the right arrow. Did you click the right arrow?
Yes.
This, yeah. Then go down, hit X, hit enter, or the middle button, either way. And then now down. And do the same thing for Y. And then go all the way, all down to 0.
Down to 0.
It doesn't let me get past this part.
Okay, so what is your slope?
Yeah, you press stat calculation.
Well, what is slope? What letter do we use
It
for
doesn't
slope?
let me go down to this. Yeah, you just get, it doesn't let me go down to stat.
Oh, that was our slope.
Stat calculation.
Unless you press it, let me get down to it.
Wait, what is it? This far?
You don't have anything. Where you're there, you're down there. Now, that's where you type
Hold up.
X,
Trip, where are
and now you type your data.
This is right.
Where is that? Well, there we go.
Which one?
The top one. Yes, the top one.
And then for column, you gotta do not.
Yeah. Okay, so when you went down and went down and clicked OK, you should have had, I mean, you'll have an M, a B, an R squared, an R, you got all these things. What is M? Represent slope. Now, we never take slope and go out to like the millionth place in decimal in. We might use a tenth, sometimes 100. So what would you looking at that big old long line or decimal, what would you say our answer would be?
Negative 1.5.
I would do negative 1.5. And then where does it cross the y-axis?
3.2.
3.2. So then what's your equation?
Y equals negative 1.5 plus.
3.2. Perfect. All right, Trip. I feel like I've lost you. Okay.
Is that the regression equation?
That is your regression equation.
Y equals negative 1.5 plus 3.2.
Mm-hmm.
So the calculator just does everything, basically.
And then is this going to be a negative or a positive?
Negative.
Negative.
Why do you say that?
Because it's
So your M is your slope.
Because your slope
And then your
is negative.
and then
Yep.
just plug those two together.
And then using the regression equation, predict what y will be when x is 10. So either using your baby calculator or go in here and hit calculate and use 10 instead of x and figure out what your answer would be.
Wait.
That's what I was trying, I turned away and you had left that page, you did it right. Yes, so there's your M, which is your slope, your B, which is that, and it's like negative 1.5. You don't have to do all those other, and then there's 3.2. Start.
I didn't need.
What does M represent?
Like
And what is B? There you go.
That's the
Use
exact
it.
same thing I did.
Do you see M?
They don't have
They had, well, they're ahead of us. So, we've got to create the equation, and so you would use that information to do it. So you would do y equals negative 1.5 x plus 3.2. It'll be right there, right? And then, is it a positive or negative correlation? Your slope says that it is negative, and then you use, instead of x, you'll use 10, and then 15. Figure out what your answer is.
No, we do not.
Coming back?
Wait, how do you add your calculator?
To your data.
I'm confused on what
Wait,
we're
wait,
trying
wait.
to do for the Do we just
Okay,
make another
come
one?
out of that.
She said it would add the calculator. Plug 10 in where.
Oh, you have to go down. Let's see. I see what you're saying. Okay.
Dude, put that. Whatever you.
Got it. We have-
Looks like she's in the business.
Stat.
Doesn't work.
Right, here's, we've got
That's mine.
extras. Oh, we have too many calculators.
Wait, what does it mean to predict y next is 10?
What does it mean, what?
Like, where do you put the 10?
Where x is. X equals 10, so you go back to your regression equation.
So then we do y equals 10 plus 3.2.
So you're going to say, now to figure out, to predict y. All right, well, we have y equals right here. Oops, I think everybody agreed. Y equals, I think we did negative 1.5 and plus 3.2. So then, now we take our x and put it where replace it with a 10. So negative 1.5 times 10 plus 3.2.
So we can put the x on this.
You can either exit out and go to calculate or get your baby out and do it. I mean, we're going to be through with it. We're going to start another.
Oh, so you can't.
You wouldn't really need it anymore.
So we exit out of
So
it?
it's
Would it be
negative
negative
11.8.
11.8?
Negative 11.8.
Wait,
But what happens when x is 15? I mean, y is 15.
say 15 equals negative 1.5x plus 3.
Because see, you're going to now find x when y is 15.
Wait, I did 4 minus 1.5. Wait,
For that one, would you still multiply by 10? Or just keep that?
Well, the first one, you're going to multiply by 10, and then we're through. We got
for
negative.
B.
For B, that has nothing to do. The negative 11.8. So we're going to find x. So you're going to have 15 equals negative 1.5x plus
So
3.2.
negative 7.
Uh-huh. Negative 7.8.
Wait, do you not round up?
I guess you could.
You get 15 minus 2.2 divided by negative.
Or it really would be, if you rounded, it would be 7.9. Or negative
Yeah, that's all.
7.9. And we know from slope that this was a negative correlation. I really wanted to do number 5. Run down to number 5. We're going to graph the data with temperature on the x-axis. So what are we going to use for our x values?
6, 8, 10.
Well, we're going to, yes, but we're going to, I counted by 5s. I did 0, and then I did 5, 10, and then just for space, I did skip 10, 15, 20, 25. And then going up for your minutes, I did it, the first one 10, but really by 10s, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110.
Wait,
I skipped it, but for space, I just didn't write in 20, 40, 60. I just skipped those going up. So let's plot. So we would have 6, 11, and 8, 29.
You went up by 5s on the bottom?
On the bottoms, I did by 5s. And then 8, 29. 10, 47. 15, 75. That's finally, well, we can't even plot the 75. It's kind of right there. 20, 109. Now, you can't connect those lines because they don't form a straight line. But you can take a ruler and line it up where it goes mighty close to the lines. and draw. Now, is this going to be a positive or negative correlation? It's going to be positive. I drew and it didn't draw. Okay. It's going to look something like that. Then you pick two points that are close. And I picked like this one, making it really big. And I picked, I don't know, you could pick this one. And use those two, you pick your own two, and find out what those actual coordinates are and figure out slope. And you're going to be able to then find your line of, put it in point slope. And then you'll find your line of regression using what we just did. Putting in the data and figuring out, like going down to G to figure out, using the graphic calculator, what your line of regression would be. I don't see you doing it. I just see you sitting. Not everybody, but a few. I hope you'll know what to do with homework, because if you're not working this, you may struggle. So what did you find slope to be? Using your 2 points, putting them in point slope.
Five over -20.
Is it not over 1?
I did, let's see. I did 10 and 50 and 15 and 80 were my two that I plugged in when I worked it.
I also got.
And you got what?
I got 9 over 1.
9 over 1?
Wait, I did 10 and 47. Are you supposed to do 50?
No, you could do 47. I mean, you pick a point. I ended up with 6. I ended up with 30 over 5. So when I did it, I used 10. I did one like right there. And then I did 15 and 80, which would have been about right there.
I got 34.
So you would take your points and subtract. All right, hold on, guys, before you run away. We didn't quite finish, but we did enough that you can do homework. This won't be bad. Putting in your X and Y. You have the blue sheet. Use the blue sheet to help you locate everything that you'll need on the graphing calculator.